If you have the settings right and the fit up is right, then there's not much motion that you need to do. Now, if you fire up and you discover that's a little bit hot, you can always come out just a little bit wider on the walls there to cool the puddle off a little bit. But I'm just doing a very slight wiggle here, staying on the front of that puddle. You can see the very front of the puddle is just trying to keyhole a little bit. Not anything crazy. It's not anything that I have to counteract by going out on those walls really far. You can see the back side here breaking the walls down pretty good.
In just a minute, I will list the settings for this uphill route as well as the fill and cover pass.
Once again, this is short circuit MIG welding, so I'm using C25 gas at 7525, 17 volts, 161 inches a minute on the wire feed speed using 035 ER70S6.
Toward the end of the video, I want to show some comparison shots between short circuit MIG, uphill cover pass, and pulse spray MIG using 9010 gas.
Gun angle is important, and I try to keep mine just about 90 degrees. Camera makes it look like it's kicked way back here, and actually it may be. Once you get to welding, the tendency is to lean the gun back a little bit. So if you shoot for straight in, you'll probably be leaned back a little bit if you're anything like me. But you don't want to get out of scope with that too much. It's pretty forgiving. Just shoot for dead nuts straight in, you'll be fine. So you can see that the technique here is just a slight wiggle. You need to wiggle far enough to sort of help the puddle flatten out a little bit. Otherwise it can be really, really crowned up on the front side. But as long as it's not crowned too much, putting that second pass in there is not a problem. A root pass like this with an open root can be done uphill or downhill. Just depends on the job requirements. Uphill is slower, but also pushes a little bit more reinforcement through the back side. Here's a quick cut and etch so you can see that profile. This is the motion that you're going to see on that second pass. And I'm going to stop short of consuming that edge. I want to leave about a 1/16 there. And I want this thing to be about a 1/16 below flush for the cover pass. And then using that technique and keeping the arc on the leading edge of the puddle. I'm not using a whole tremendous amount of gun angle here, just a slight push. The gun is kicked back just a little bit. Straight on works fine too. I've seen people even use a very slight drag, but you tend to get a little bit of a crowned fill pass when you use a slight drag. That one there is pretty flat. I let it cool down to about 150 degrees or so and shined it up a little bit with a wire wheel to get those silicon islands off of there. One more pass to go. Now this one is going to be almost the same exact technique as the prior pass. So you can do a straight Z-weave, or you can put just a little bit of an arch in the motion. But you want to hold those toes for just a count, come across the middle fairly quickly, and overlap those edges by just only about a 1/16 of an inch. It's about 1 second per going across. Let's see. Okay. All right. 1001, 1002, 1003, 1004. Just pretty close. Again, holding the toes just briefly and not spending a whole lot of time across the middle. I'm not bouncing from side to side. I'm just not going really slow. And then I'm trying to overlap those edges of the bevel just by about a 1/16 of an inch and trying to do it the same each time. So all these things, if you do everything the same, what happens is you get a pretty uniform weld. The weave pattern is pretty uniform. The edges are straight. The edges are uniform. The height of the reinforcement is uniform. You know, you just kind of got to train yourself to do things uniformly. Be as much like a robot as you can. And the benefit is you're not a robot, so you can make little adjustments as you go. If you see a little bit of a high place or something, you can move a little quicker over that. You can notice the joint next to that is all cleaned up and ready to weld. That's in case I screwed up.
I mentioned pulse spray earlier. I filmed lots of pulse spray videos with my friend Matt Hayden. The full-length videos are posted over at welderskills.com, but I borrowed some of those clips for this video just to show you the difference between uphill short circuit and pulse spray MIG. Here we go.
You need a machine capable of doing pulse spray in order to do it. An extra setting that usually is on machines with pulse spray is called trim, and that definitely changes the arc length and the sound Up in the right-hand corner, the 1.03 is the trim setting. Over on the left, 190 is the wire feed speed. Program 12. If I had the sound turned off here, you might think this was short circuit MIG all over again. But it's a variation of the spray transfer process. It's just a lot more controllable. Certain welding codes really discourage short circuit MIG for structural welding. But since pulse spray MIG is just a variation of spray transfer, it's looked upon a lot more favorably by the welding codes. All right, let's look at them again one more time back to back. First we'll show the short circuit MIG, and I'll turn the volume up and I'll keep my mouth shut. Then the pulse spray.
I'd appreciate it if you'd hit the subscribe button. Here's a few videos on vertical uphill MIG as well as 7018.